Welcome. In this video, we'll begin a guided tour of building the standalone template project, with the first step being to configure the tiler Python script. The tiler can use layers in vector or raster format, in any type that is supported by the GDAL library. GDAL stands for Geospatial Data Abstraction Library, and provided here are two links to the supported formats. The tiler script makes use of a prepared Python package called Mojadata, which is the library for converting the spatial layers to Flint format and dealing with things like resampling and reprojections. A project template called tiler.py has also been prepared, and the user can find it at the path indicated. The first thing that needs to be done in the tiler.py file is to configure the bounding box, which defines the study area of the plant simulation. All of the other spatial layers are cropped, reprojected, and resampled based on the parameters of the bounding box. One important thing to note about the bounding box is that it is pointing to the inventory.shp file. It can point to any spatial layer, but in this case it will be left as is. Next, the user must identify an attribute within the chosen file to define the simulation area. In this example, the polyID attribute was selected, which represents all of the polygons in the landscape, each having a value. Next, the user must identify the pixel size, which represents the resolution at which the simulation will be run. There are two data layers identified in this file, initial forest age and mean annual temperature, which is optional. Further down are disturbance layers indicating the type and the year of disturbance. The next few slides contain reference layer information and examples that users can refer to in the future if the need be. Users should remember that layers are specified using raster and vector layer classes. Now we'll discuss the classifier layers. These are what link the forest inventory spatial data to the yield table. In this example, there are two classifiers in the spatial inventory layer, as well as in the yield table, polyID and province. Returning to the previous tiler script, the classifier layers can be seen on line 56. This is where the user defines the vector layer classifiers, and they can enter any names they wish to represent them. The classifier names identified here just need to match the classifier names that will be defined later on in the recliner to GCBM script. Also identified here are the paths to the shapefile and the classifiers whose attributes will be used, in this case classifier 1 and classifier 2. Finally, there are the classifier tags, where the user can tag layers with user-defined strings representing bits of metadata about the layers. The next step is to include any required or optional data that the user may have. In this case, there are two attributes that need to be added here, initial age and mean annual temperature. In the last step, the user will add their disturbance layers. The requirements for setting up the disturbance layer include the year being in a 4-digit format and the value of the disturbance type variable, disturbance_type, matching the disturbance type name in the project input database. Once the tiler script has been set up, it can be run by itself using the process_spatial_layers.bat file. It can also be run with the run_all.bat file, which runs all of the pre-processing tools, the simulation, and the post-processing tools together. Once the script runs, the final GCBM format layers should appear in the tiled subfolder in the layers folder. Displayed here is some of what the user will find in the output: a TIFF file of the final cropped or reprojected version of each layer, a CSV file called transitionrules.csv that contains transition rule data from the disturbance layers, and the study_area.json file that contains metadata about the tiled layers. The other scripts can also use this JSON file to configure the GCBM. A log file for the tiler script called tiler_log.txt will also be found in the logs folder. And finally, a Flint format layer will be found in the tiled subfolder of the layers folder. This layer consists of the fully preprocessed GeoTIFF layer and a metadata file for the layer in .json format, the most important components being layer_data, that is the data type of the layer, no data, that is no data value of the layer, and optional attributes, that is map the pixel values to either a single attribute value or a table of attribute values. With a successfully configured tiler, the next step is to generate the input database, and this will be discussed in the next video.